Hello everyone, I'm Mrs Jennison and I'm an Associate Director for our Grange Academy's Trust. Welcome to our next lesson. In today's lesson we are looking at the electrolysis of aqueous solutions. As with all of our lessons, it will be really useful if you had a pen and a piece of paper so that you could work through the activities with us as we go along. Now our challenge is to be able to describe how electrolysis splits a compound and predict the products of electrolysis. Our aspire is to be able to explain electrolysis in terms of oxidation and reduction. And this lesson will focus on aqueous solutions, whereas in our previous lesson we focused on molten compounds. Now you may remember from last lesson that electrolysis is the splitting up of ionic compounds using electricity. Now this only works with molten or dissolved ionic compounds because the ions are then free to move. And in today's lesson we will focus on the electrolysis of aqueous solutions, meaning when the compound has been dissolved into water. Now, solutions in which water is the solvent are called aqueous solutions, and they are typically followed by the symbol bracket AQ. Now, examples are the ionic compounds below. Now, once sodium chloride is dissolved in water, that solution is now called an electrolyte. The problem is that even though water is covalent, it will dissociate in water to give two ions, hydrogen and hydroxide. These ions will then also be attracted to the electrodes. So what products will we get? Well, it depends on the compound. So if an ionic compound contains a metal that is more reactive than hydrogen, the electrolysis of this solution will produce hydrogen, not the metal. Now at the positive electrode, if the ion in the compound is a group 7 ion, for example fluoride, chloride, bromide or iodide, the electrolysis of that compound will form the group 7 element. So it is those ions which will discharge. Otherwise, oxygen will be formed from the hydroxide ion present. The half equation for that is shown on the screen. So 4 OH- ions will discharge and that forms oxygen, water and 4 electrons. Now you may remember from last lesson when we looked at Leo the lioness's Gur. If something loses electrons, it is oxidised, and if something gains electrons, it is reduced. Now that we've looked at this, Okay, so we're going to have a look at the negative electrode first. And obviously that means that is where our positive metal ions are attracted. Now, alongside the positive metal ions, we will also get the hydrogen ion attracted. And as potassium is more reactive than hydrogen, hydrogen gas will form. Copper will form for copper sulfate. Again, sodium is more reactive than hydrogen, so sodium will not form, hydrogen will form for sodium bromide. Silver would form for silver nitrate, and again, hydrogen would form for zinc chloride, as long as they are in solution. Now, the positive electrode, remember the rule is if it's a halide ion, it will be the halogen that forms, and if it's anything else, oxygen will form because of the hydroxide ion. So potassium chloride will get chlorine forming, copper sulfate will form oxygen, sodium bromide we will get bromine forming, silver nitrate we will get oxygen forming from the hydroxide ion, and zinc chloride we will get chlorine forming. So what happens to the remaining ions? Well, the remaining ions will actually stay in the solution. So let's take sodium chloride as an example. And as you can see on the diagram on the screen, we've got sodium and chloride ions, we've got hydroxide ions, and we've got hydrogen ions. Now, in this example, sodium and hydrogen will both attract to the negative electrode. Due to sodium being more reactive, hydrogen gas will form. That leaves sodium behind in the solution. Chloride and hydroxide will attract to the positive electrode, and chlorine gas will be formed, which leaves hydroxide ions behind. So now we've got sodium ions and hydroxide ions left in the solution, which means there are technically three products to this electrolysis: hydrogen, chlorine, and sodium hydroxide, which you may remember from an earlier unit is an alkali solution. So now that we've gone through that, there's a few exam questions for you to have a go at. Student investigates potassium salt. She finds that salt acts as a high melting point, does not conduct electricity when it's solid, dissolves in water, and the solution does conduct electricity. What is the type of bonding in salt X? And what is the name given to solutions that conduct electricity? Why does a solution of salt X conduct electricity? And then the student electrolyzes the solution of potassium chloride, and they want you to explain why hydrogen is produced and not potassium. Okay, so it was ionic bonding. The solution is called the electrolyte. Conducts electricity because the ions are free to flow. Potassium is higher in the reactivity series than hydrogen. You could have said it's more reactive than hydrogen, so it's less easily discharged than hydrogen is. Okay, so for the next part of the lesson, we are going to look at some higher tier content. During electrolysis at the cathode, which is your negative electrode, positively charged ions gain electrons. So the reactions are reductions. At the anode, positive electrode, negatively charged ions lose electrons, so the reactions there are oxidations. Reactions at the electrodes can be represented by half equations. Now the two examples I've shown you here are the half equation for hydrogen and the half equation for hydroxide. I did mention these earlier, but remember, when you are looking at oxygen forming at the positive electrode, it is the hydroxide ion being discharged. So there is also water being produced. It's really good practice to learn these two half equations because you could be asked for them. Now, the images on the screen show the electrolysis of brine with universal indicator added to the solution. Now, I want you to think about what we have looked at so far in terms of the electrolysis of solutions. So brine is sodium chloride solution. It's literally salt water, but very, very concentrated. So what ions would be in that solution? Try to have a go at explaining what is occurring at each electrode. I'm not going to use a timer for this, so if you want some time, just pause the video and have a little bit of a think. Why have we got purple solution over here? Why is the universal indicator turned purple? What causes that? And over here, what's caused it to turn red and bleach? Now, the purple side, the product being formed is hydrogen on this side, but the water around this will ionise and you're getting sodium hydroxide being formed. So that is where our negative electrode is. On the left side, we've got our positive electrode, and that's where chlorine is being formed. Now, chlorine, you might remember the test for chlorine from gas tests. It will bleach litmus paper. And this is because it will dissolve into the water. And first of all, it'll form an acidic solution, which is why there's red showing on the first image. But then it will bleach the colour from the indicator, which is why we're getting that colourless section. Now, just an example of a higher tier question for you. This question is about electrolysis, and figure 1 shows the apparatus used to electrolyse silver nitrate solution. They want you to name the product discharged at each electrode and write half equations for each electrode. Figure 2 shows the apparatus used to electrolyse sodium chloride solution, brine. Hydrogen and chlorine are produced. Explain how another different product is formed in solution during this electrolysis. So silver is forming, which would be Ag plus an electron forming silver. So 2 marks for each of those. Then a mark for the oxygen and a mark for the half equation from the hydroxide ion, remember. So 4OH minus forms oxygen, 2 water molecules and 4 electrons. Then for the second part, there are 4 ions at the start of that electrolysis: hydrogen hydroxide, sodium and chloride. The hydrogen's discharged at the negative electrode. The chloride is discharged at the positive electrode, which means we've got hydroxide and sodium remaining in that solution, which means it will be a sodium hydroxide solution. That's everything for me in this video, and I will see you soon.